Assalamu alaikum everyone. I hope everyone is fine at home and you have already done the previous homework. So we were discussing about eigenvalues, eigenvector. So today we will continue our previous lecture. So today our topic is about characteristic equation. So now first, what is the definition of this? So the definition of this is determinant. So this det, determinant of a minus lambda I equal to 0, is called the characteristic equation of the square matrix A. Note that we find eigenvalues by using the characteristic equation. So what is the benefit of this characteristic equation? So we can find eigenvalues. Previously what we were doing, we were given eigenvector, and then from that I can find eigenvalues, or if there was eigen value given, then I can find eigenvector. But now from this equation, if even eigenvector is not given, only the matrix A is given, I can find eigenvalues. So here the most important thing is, so we can find eigenvalues definitely of the square matrix. So if the matrix is square, and then I can find first a minus lambda I, where I is your identity matrix, and then I will find determinant. I will put equal to 0, and from this I will get an equation. So that will be, if it is say 2 by 2 matrix, so you will get a quadratic equation. It will be 3 by 3 matrix, so you will get a cubic equation, and so on, cubic polynomial like this. So then we will solve that polynomial, and we can get the value of lambda. So this is the main scheme. Now I will solve the question. Find the eigenvalue of the matrix A. Now the matrix A is given as 2, 3, 3, minus 6. So what we will do, so we will find A minus lambda I. So the matrix A is given this, minus lambda I, identity matrix this. You can multiply lambda inside, and then you can subtract this, so you will get 2 minus lambda, 3, 3, and minus 6 minus lambda. Now the characteristic equation is determinant of a minus lambda equal to 0. So now you can find determinant of this. So determinant of this, and you must put equal to 0, and you know how to solve the determinant. You multiply a with d minus b with c. So now you can multiply 2 minus lambda with minus 6 minus lambda, minus 3 with 3, so minus 9 equal to 0. Now you can multiply 2 minus lambda with the minus 6 minus lambda. So if you multiply 2 with minus 6, it is minus 12. 2 with minus lambda, it is minus 2 lambda. Minus lambda with minus 6, it will be plus 6 lambda. And minus lambda with minus lambda, it will be plus lambda square. Minus 9 equal to 0. And then you can rearrange, simplify. So this will be lambda square plus 6 lambda minus 2 lambda, it will be plus 4 lambda. And minus 12 minus 9 is minus 21. So we get lambda square plus 4 lambda minus 21 equal to 0. Now you can make factor of this. So it is lambda minus 3 and lambda plus 7, because minus 3 plus 7 is plus 4, and when you multiply minus 3 with plus 7, so it will be minus 21. So it means one time lambda minus 3 equal to 0 and lambda plus 7 equal to 0. So the value of lambda is equal to 3 and lambda is equal to minus 7. So these are the required eigenvalues. So this it is very simple. What you have to do, only you have to find the characteristic equation, and then you can put equal to 0. Determinant of a minus lambda I put equal to 0. You will find the characteristic equation. So this is your characteristic equation actually. Lambda square plus 4 lambda minus 21. So this is the characteristic equation. So sometime in exam we can ask only this question, find the characteristic equation. So if I ask to find the characteristic equation, you will stop here. But if I ask find the eigenvalues, so then you will find lambda value also. Now if you want to recheck your answer, whether this is correct or not, so there is a theorem, and the theorem says if the sum of the diagonal values, this is diagonal 2 and minus 6. So if you add this diagonal value, it must be equal to sum of the eigenvalue. So if you see the eigenvalue sum is 3 and plus minus 7, it is minus 4. And if you add the diagonal values 2 minus 6, so it is also minus 4. So it means our answer is correct. So in this way you can also recheck your answer in this case. Okay, the next question is find the eigenvalues of the matrix A. Now it is a 3 by 3 matrix, so now we have to find eigenvalues for this. Again we find the correct equation. So for that we find A minus lambda I. So here your I will be identity matrix of 3 by 3. So if you solve this. So a minus lambda I. So because you know if you see if you have seen this last, so lambda when multiply inside with identity matrix, it will multiply only with the diagonal entities. It means 1 1 1 like this. So you can no need to do this step. You can directly write this step if you understand this. So that is why here if you can see I have written here direct step. So I multiply lambda with I, so I will get this, and then you can subtract this. So we end up with minus lambda 1 3 0 1 minus lambda 4 minus 2 2 and 1 minus lambda. So now the characteristic equation will be, I will write determinant of a minus lambda equal to 0. So you can write determinant, put equal to 0, and now again you know how to solve this 3 by 3 determinant. So I open with the first row, you can open with the second row, it's up to you, minus lambda. So if you open with the first row, so this will cancel this, so you will write this, and similarly you know very well how to find determinant. So you simplify this. So simplify this all. I will not explain this because you know this multiply this minus 2 multiply with 4. So this is I think very clear. We solve many times. Now you can multiply this inside lambda with minus lambda multiply with this, and minus lambda will also with 8. Similarly minus 1 with 8, minus 8, then 3 with these values. So minus into minus is plus, so this will be 6, 1 minus lambda. Again you can simplify this. How we simplify this? So minus lambda, this 1 minus lambda whole square minus 8 lambda minus 8. So you can take here minus 8 common. If you take minus 8 common from here, so it will be then 1 minus lambda plus 6 1 minus lambda. Now you can see 1 minus lambda 1 minus lambda 1 minus lambda. This you can take common from all. So so we will be it will be left with minus lambda and 1 minus lambda, because 1 minus lambda we took common. So 1 minus lambda will also left here, and here left only minus 8, here left 6. So if you simplify, so 1 minus lambda multiply inside, so minus lambda minus plus lambda square, and minus 8 plus 6 is minus 2. And again if you simplify, so this will be lambda square minus lambda minus 2. And if you make factor of, so 1 minus lambda can be equal to 0, or lambda square minus lambda minus 2 can be equal to 0. So here we can again factorize. So if we make factor, so this will be lambda plus 1 and lambda minus 2. The reason is minus 2 plus 1, it will be minus 1, and minus 2 multiplied with plus 1, so it will be minus 2. So then lambda plus 1 can be equal to 0, or lambda minus 2 can be equal to 0. So the values of lambda, if you solve this, 1 minus lambda equal to 0. So the value of lambda is equal to 1. If you solve here, lambda is equal to minus 1, and if you solve here, lambda is equal to 2. So we get 3 eigenvalues, because it was 3 by 3 matrix, so there will be 3 eigenvalues. And now if you sum all these eigenvalues, so 2 minus 1 plus 1, so 2 plus 1 is 3 minus 1, so it will be 2. And if you want to recheck your answer, here is the matrix. So sum of all the diagonal values, you can see here 0 plus 1 plus 1, so it is also 2. It means our answer is correct. So I think again, if I will ask this question only, find the characteristic equation, and characteristic polynomial or characteristic equation, so you will simplify this, and no need to find the value of lambda. But if I ask find eigenvalues, then you have to solve like this. Sometime maybe this factorization will be a little difficult. So what I recommend, you can simplify this all and make this a cubic polynomial. And then cubic polynomial, even you can solve direct on your calculator. You can find roots of the cubic polynomial easily. Quadratic polynomial, you can also find roots of the quadratic polynomial, and you can also find roots of the cubic polynomial. So in exam maximum, we will ask question of the cubic polynomial. So if you don't know how to make factor of this, you can use calculator, so there is no problem at all. Okay, next homework is find eigenvalue of the matrix A, 3 minus 2 1 minus 1. So very simple. So this is your homework, so please try to solve this. Very simple. Now next is eigenvalues and corresponding eigenvector. Now for example, first you can we find eigenvalues by using the characteristic equation, and then you can find the corresponding eigenvector also. Eigenvector we will find like we done already. But now we will find by using the characteristic equation. First we find eigenvalues by using the characteristic equation, and then we will find eigenvector. So note that for each eigenvalue we can find a corresponding eigenvector, and obviously it must satisfy mv is equal to lambda v. M mean any matrix. Mostly we write a v equal to lambda v. A is any matrix, so here I have written mv equal to lambda v, where m is any matrix. So we will apply the same rule. Now the question is, find the eigenvalues and corresponding eigenvector of the matrix A. So now here the matrix A is given. So first you will find the eigenvalues by using the characteristic equation, determinant of A minus lambda I. You know how to solve this. So first we find A minus lambda I, and so then you will find determinant of this, put equal to 0. You can find the roots of this. Again, you know how to solve this. You can simplify this. So you will end up with lambda square minus 3 lambda plus 2. You can make factor of this. So this will be lambda minus 1, lambda minus 2 equal to 0. So therefore your eigenvalues are lambda is equal to 1 and lambda is equal to 2. This you already know how to solve. Again, if you want to recheck your answer whether it is correct or not, so you can add these two eigenvalues. So lambda is equal to 1, lambda is equal to 2. So this is 3. And if you sum this eigenvalues, diagonal values, so 4 plus minus 1, it is also 3. It means our eigenvalues are correct. Now we will find corresponding eigenvector. Now to find corresponding eigenvector, so first we will find eigenvector for lambda is equal to 1, and then we will find eigenvector for lambda is equal to 2. Now for lambda is equal to 1, we can assume that v1 is equal to xy be the corresponding eigenvector. So you already know how to find eigenvector. So when lambda is equal to 1, we know a minus lambda I. So your lambda value is given as 1. So I can substitute this a minus 1 I. So a minus I, you can simplify this. So we get this. And now we have a minus lambda I into v1. Why I have written v1? Because this will be our vector. So v1 equal to 0. So now this is a homogeneous system of equation, and you know how to solve this homogeneous. You can, instead of in previous lecture I have written here x, a minus in the previous lecture I have written a minus x lambda I. So the equation I have written a is equal to a x is equal to lambda x, and then you can take this other side, and then you end up with a minus x a minus lambda I, and then here x. So instead of writing x, I am writing here v1, because I introduce v1 as my first eigenvector. You can see here v1 xy. So this is my first eigenvector. So a minus I v1 equal to 0. So this is your homogeneous equation. You know how to solve this. So this will be 3x minus y 3. So this is a minus I, and this is v1 equal to your 0 matrix. So this, if you multiply this, so this will be 3x minus y equal to 0, and then 6x minus 2y equal to 0. So what you can do, you will surprise why I am solving now here in different way. And previously what I did, I solved this by using the row reduction, and then I find the eigenvector. But if it is 2 by 2, you can direct even solve. There is no problem. It's very simple. No need to use even row reduction method. You can solve this direct. The reason is, here you can see 3x minus y is equal to 0. So you can write y is equal to 3x, and 6x minus 2y equal to 0. So this is also y is equal to 3x. So it means we end up with y is equal to 3x. So therefore, if your x, if you put here the vector v1, so x, and what is your y? Y is your 3x. So now you can take x common, so it will be 1 3. So then you can, because x is a free variable, so you can choose any one. So you choose x is equal to 1. So your first eigenvector is 1 3 for for eigenvalue 1. Now we will find for lambda is equal to eigenvector. So for that I will assume another vector. I will call this as v2, be the corresponding eigenvector of the matrix A. So when lambda is equal to 2, again I can find a minus lambda I, so a minus 2i. So you know, you people know how to find this. So a minus 2i, so we end up with 2 minus 1 6 minus 3. Again you can solve, I said this, by using row reduction method, or you can solve directly like this. So a minus 2i v2 equal to 0. So this a minus 2i, and then v2 is your xy equal to 0. So again you can simplify this, you multiply this inside. So this will be y is equal to 2x, and again here we will get y is equal to x. So it means your x is free variable, so y you can replace with 2x, x you can take common, so it is 1 2, and again you can choose x. I said x is a free variable, you can choose easily x is equal to 1. Other than 0 you can choose anything x. So here we choose x is equal to 1. So therefore your other eigenvector is 1 2. So I think very simple. Try to solve the homework. You know, your homework is find eigenvalues and corresponding eigenvector of the matrix A equal to 2 7 7 2. So I hope today lecture is clear. So this lecture again will be lecture number 10 and lecture number 11. So if you have any question, any problem, in our next lecture on Moodle, inshallah I will answer your problem, but try to solve this homework. This is very important. If you solve the homework, then your concept will be even more clear and it will be more easy. So please stay at home and stay safe. Take care of yourself. Assalamu alaikum.